Yep. All right, so we are recording now. So it's March 16th, 2023. We will complete our discussion on SQL with this lecture slide, set of lecture slides. It's titled Advanced SQL. I don't really prefer it being called that because it's not so much that it's advanced. It's not like the previous stuff we were doing was basic and this is more advanced in some way. It's really just more a matter of this is more the what we call the data definition language side of SQL. The previous stuff we talked about was the data manipulation language, the DML side of SQL. So what we learned last week and yesterday was about how to get data and how to manipulate, whether it be add through insert, change through update, or remove data through delete. Those are the three things we talked about specifically as far as changing data is concerned. But then we also talked a lot about select, about how to get data through a select statement. Yeah, so this is basically what's called a SQL injection or SQL injection. It's a very common way to try to attack a database side of thing. So what you will understand is specifically what I wanted to point out was this part right here, the drop table students. That is going to be how we get rid of a data structure. How do we get rid of a database structure like a table or a view or even a column within a table? Is going to be using the drop keyword. So make sure you know the difference between the drop and the delete at the end of this lecture, and we'll also talk about the other stuff about the different keywords for the data structure, how the database structures themselves, about how to create, how to alter, how to drop the database structures themselves. Okay, so let's just get right into it. All right. Well, the first thing we're going to talk about is some of the data types that are supported by SQL, how to define integrity constraints. Some of the discussion will be centered on views and why we use them and some of the advantages and disadvantages. And then where we'll end is about privileges, so how to grant and revoke privileges for the purposes of security. Okay, so some of these data types look very familiar, I'm sure, in terms of their keywords, like the Boolean keyword, the character char keyword, integer for class type in Java, float, right, as well. All right, so these are all data types that we can use in SQL. One new one that you probably haven't heard of before database discussions was this varchar or variable character. Okay? So that is a character string type. Char or character is not just a single character. You can define a length for it. So you can say, I want a char field that is of size 4. Varchar is more, it's variable, so it kind of varies how much space it takes up based upon the length of the string, whereas a char field will take up the same amount of space because it expects to have that many characters. Okay, so that can be why the variable character is used. We also have these things called a character large object or a binary large object referred to shorthand as clob and blob. I have seen blobs used pretty frequently for large text or character or clob for large text, large amounts of text. There are some limitations in that. They're useful for if you need to store a large amount of text into a field. Can be difficult for using in terms of searching if you're wanting to try to limit the number of results based on some text that is in that field. Okay, but basically, other than that, it's a lot of the same data types that you're used to from previous programming experience from Java or whatever. You should all know Java, but if you also know other languages like C or Python or things like that, some of these data types are the same. All right, so let's talk about some of the integrity constraints we may run across that would be common. Required data. If we have a piece of information that is required, such as a name. If you're a student registering for a university, everyone has to have a first name, right? Everyone also has to have a surname, right? Now, some people have middle names, but that's not required, is it? In fact, many of you in this class don't have middle names. And I would actually argue that none of us have middle names as far as the Turkish system and the Kimlik system and the university system is concerned, because if you look at my Kimlik, which, where did I put it? Maybe I won't put it up here. All right, let's see. Oh, it doesn't show it on here. Oh, it's on something else. I can't find it. But my first name is Joseph William. My surname is Lede, according to the system here. That's how they've decided to handle the issue of first name, last name, and some people have middle names, is that basically they take everything except for your surname and make it your first name, right? But that would be a piece of required information, right? If I'm applying for a job at the university, or if I'm applying to be a student at the university, I have to provide my name and surname. There's some other information that might be required depending on the system. So for example, if you sign up for let's see, maybe like a Hepsiburada account or a Stack Overflow account or something like that, they might require you to give an email address or something like that. They might not require you to have a phone number. All right, so that would be some type of example of not non-required data. Okay. Domain constraints can be if we want to say a certain field has to be within a certain domain. It can only be within a certain value. We'll see an example of that, which won't get into politics, but some people may say, hey, that's not a good example. We'll talk about that in a moment. Okay. Let's talk about, so entity integrity would have to do with what we call the primary key. We talked a little bit about that a couple of weeks ago. But the idea of the primary key being a unique identifier, that it has to be filled, like there has to be that field has to exist. So for you to exist in the university system, we have to have a student ID for you. All right, for me to exist in the university system, I have to have an employee ID. Referential integrity, we talked a little bit about that before, having to do with if there's a relationship between one table and another, where let's say, for example, this course has a list of students associated with it, and then we don't store all of your information in the course, right? We don't store your name and your birth date and your email address and all of those things. The only way that we know that you are in this course is because there's a table out there that has, for this course, your student number, and that's it. It doesn't have anything else. By having this course associated with your student number, that's saying you are in this course. Okay. On the other hand, there's also in that same table, I'll just tell you the way that it would be designed, if it's designed well, is you would have your student number has a course field where it has a reference to the course table that has to tell me that you are in this course, and it tells you all the other courses that you're in by having just a your student number has this course and every other course that you're taking as a field there. Now, why do I talk about all this? Because referential integrity says that in order for that to work, if I'm going to say this course has your student number in it, then there better be in the student table, there better be a student number in that field that matches to you, okay? That matches to somebody, right? Because if I have a student number in this course and that student number does not exist in the student table, that doesn't make any sense, right? That can't work. Right. And then there's some other things like general constraints where we can have some other constraints. We'll talk a little bit about that. But really those first four, required data, domain, entity, and referential integrity, I would really argue, honestly, required. Let's go entity and referential are probably the most important that we'll talk about. Required data can be, it's whether or not a field can be null or not. Some domain constraints, because not everyone uses domain a lot. And then general constraints. Okay, so maybe for future, I'll reorder this in terms of what I think are most important. All right. So we can have an required data by simply saying a column cannot be null. All right. If we say that a column can't be null and someone tries to insert a record or a row where that column is null, this will reject the insert. Okay, so that cannot happen. We cannot have a we cannot have somebody put a row in there where that column is null if we have a not null constraint on there. We're saying it cannot be, it's required. Okay. This is the example of the domain constraint, right? Where we're going to check the sex or the gender of someone, and it's a character. It cannot be blank. And we're going to check that it is in M or F, male or female. Okay. So again, I'm not going to get into all the other possible ones here. Facebook offers other options, but for the purposes of this example, what we're saying is it's going to be one of those two. If someone tries to insert a row where the sex value is either null or not one of these two, then it will reject that insert. Okay. We'll see some examples of this too, because one of the things that you'll ask, I'm sure, is, well, what if I'm inserting lots of rows? Because Hojam, you said last time, you said yesterday that we can insert lots of rows all at once, and we can insert thousands of rows all at once. So what happens if I have someone who writes a SQL statement or writes an insert statement or uses my application in some way that it tries to insert a dozen rows and only one of them fails the check? Only one of them is not okay. Does it insert the other 11 rows and just not insert the one, or does it reject the whole thing? We'll talk about that. We'll see that as an example, because that's a good question, because well, how should it work might be the question here. All right. So, all right. By the way, this whole creating domains, this is something that MySQL does not currently support. I was checking it before class just to make sure. It hasn't in previous versions, and it doesn't now. So the creating domain is a good thing to know for future reference, but it is not something that MySQL currently supports. But other DBMSs do, and so that's the reason why we include that, even though we're not going to be able to show examples of it in the MySQL, is because it is good information to know for other DBMSs that you may work with. Okay, let's see. Okay, domains can be removed using the drop domain. So drop, basically what you're going to notice, what you will notice is that create is how we create something. Makes sense, right? Drop is how we remove something. Okay, that is for structures, not individual rows. We do not create a row by the create statement. We do not get rid of a row by the drop statement. We add a row by using the insert statement. We remove a row by using the delete statement. Okay, so that's make sure you know that. Make sure you know the difference there between those. All right. So entity integrity refers to that a primary key must contain a unique non-null value. So we cannot have nulls as part of a primary key. All right. So we can set that a primary key is a column, like a client, like staff number. We could also set that a primary key could be the combination of two columns. Okay. Now, this does not mean that the primary key, like in the 2-column version here, this does not mean that the client number cannot be repeated. This does not mean that the property number cannot be repeated. What this means is that the combination of a client number and a property number cannot be repeated. Okay, so what that would mean is, let's say we had the example of student and course. So we're trying to see students who are in a course. All right. Now, we could say well, if we said the primary key is student, well, then that would mean that a student can only take one course. Right? Every student can only take one course. Well, clearly that's not the case, right? Many of you are taking other courses this semester. Also, on the other side, the course ID cannot be unique, right? Because if the course ID was unique, it would say there was only one student in the course. Well, I count, over 50 of you guys in this course right now. All right, and so clearly that can't be the case either. All right, so what must be going on is that somewhere there's a table that includes a student number and a course ID as part of a primary key. And I say part because you know that some of you are taking this course for the second time, which means it can't be student ID and CSE 204 together is unique because you've taken it before. Right? But what is probably the primary key on a table out there somewhere, what possibly is, depending on how they designed it, is student ID, course ID, and semester ID, right? Or something like that, where we're saying you can only take this course once in the spring of 2023, right? You can't take this course twice in the spring of 2023, right? This course can only have you once in the spring of 2023. Right? So I can't have you twice in here, right? That kind of thing, okay? Now, we can only have one primary key per table. There's only one, remember that there's a candidate key, which is a set of columns that uniquely identifies the row. A candidate key that's chosen, that's elected, right? We have an election coming up, so we'll probably talk about that a bit, right? But there's a candidate that is elected, that is chosen to be the primary key. It wins the primary key battle, right? And once it becomes the primary key, it is the only candidate key that can be the primary key. You cannot have more than one primary key. Now you can have other candidate keys or other unique columns, right? That we can say, okay, I want a column to be unique even though it's not the primary key. All right. And what'll happen is if we try to insert a row with a duplicate telephone number, for example, in this example, it will reject that insert. Or if we try to update a table and change a telephone number to one that already exists, it will reject that. Okay. So a telephone number might be one of those things that could be unique for, like, let's say Migros, right? I just actually earlier today I had to go buy some things at Migros, right? And what did they ask me? They asked me, are you a Migros customer? Do you have a Migros card? And I can enter my telephone number in there, right? Actually, it's my wife's, but so I enter that phone number in there. No other customer can have that phone number. Is that our primary key? Maybe, but it might just be that it's a unique thing. We might have some other value that is the primary key. All right. All right. In addition to entity integrity, we'll talk about referential integrity. Now, we have a foreign key is a column or set of columns that links a child table to a parent table. In the parent table, the primary key must exist, right? So if we say foreign key branch number, say for example, the branch number column in the staff table references branch, okay? So we can say, if we try to add a staff person and we try to add them to a branch that doesn't exist in the branch table, this will say, nope, you can't do that. All right. Okay. Which makes sense because they can't work at a branch that doesn't exist. You can't be in a course that doesn't exist. Okay. All right. So then what happens though? Because sometimes, right, if an insert or an update attempting to create a foreign key value in a child that doesn't match the primary key or candidate key value in the parent is going to be rejected. Okay, but what happens if we do some type of insert, update, maybe not an insert, but an update or delete from an update or delete on a parent table that affects a child. So not this course, but which one was it? My sysadmin course, maybe? I can't remember. Let's say that a course ID changes. Okay, so I can draw over here. All right, so we have this course table, right? With an ID field, and one of the IDs is, God, this is so hard to write on here. CSE 204, right? And then we have, like I said, we have this table out here that represents students taking a course, right? And let's say CSE 204 is here, 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 and all the students that are taking the course are here. And then the university decides, you know what, we don't like CSE 204 being the number. For some reason, we think that it should be 212. And there's actually a reason that they might do that. Not with this course specifically, but there are reasons that we change course codes based on subject matter. So let's say that they change this to CSE 212. Okay. Now all the values over here are 204, which creates a problem, doesn't it? Because if we're having referential integrity being maintained, now we have course IDs here that reference a course that doesn't exist because there is no more 204 over here. So what should happen? What should happen? What do you think? If I change the course ID in the course table, so this is course here, and this over here is schedule or something. I don't know what we would call this. Okay, so if we change the course ID, all right, so 204 doesn't exist anymore. Right, but what should that action be? That's what I'm asking, is what should happen when this course ID changes, because we can't leave it like this, right? We can't have 204 over here. 204 being here is a no-go, right? Because there is no 204 over here. So what action should we take? What do you think would be the most reasonable action to take here? Anyone? Okay, so if I'm understanding you correctly, Arjun, is what you're saying is what should happen is this also gets changed to CSE 212, right? That this, if a change is made here in the course table, we make that change also happen in any child table, in the schedule table, and anything else that might use that ID. Is that correct? Is that what I'm understanding you to say? Yep. Okay, yep. So what you just said, what you just defined, was this option, the cascade option. Okay, and what that means is if we make a change in a parent table, cascade that change down to the other tables, okay, to other children tables that have this field as a foreign key. Okay, that's a very reasonable option. It's not the only one, because what if we delete this course? Okay, if we were to delete something, let's say that we delete. How do you cascade in a delete? All right. Well, we remove all the students from that course. Oh. Now, if the course doesn't exist, removing the students from the course, that might be okay. All right. But sometimes when we remove or change something, we don't want to get rid of those things, right? We maybe, what happens if, so for a previous example was if a staff is managing a property, right? Remember there was a property for rent table and it had a staff number field. And in that field was who was managing that property. Well, if we delete somebody from the database, from the staff table, because maybe they got fired or they quit or morbidly they died, you know, those are options of why someone might get deleted from the table, right? Well, we don't want to remove the property just because they're not managing it anymore, right? That would be a bad thing. So what might we do in that situation? So if we don't want to, remove the property, but we can't leave it being managed by somebody who's not in our system anymore, right? So what could we do in that situation? If that question is clear. Like an is active already, well, you're thinking about more like how to design this in a different way so that we don't delete people from our database. I'm specifically saying, what if we have a staff person, right, with a staff number, and there's a relationship to the property for rent table. And there's a field there, right? There's a field there that says who it is that is managing that property. And let's say we remove this from the database. We don't want to delete the property, right? We don't want to delete the property. We want to leave the property there. But what can we do with this field here? This foreign key column that points back to the staff, and that staff person doesn't exist anymore in our system. What can we change that value to? Okay, so Seamus is suggesting maybe a default value, right? So maybe we set it to the default of the manager for the branch that they work at, or they set it to something else, right? If we allow this foreign key column to be null, right, we could set it to null, right? That way we say we just leave it blank, and any properties that are blank are not being managed right now. They're not being, and we may need to change that at some future date to give it to someone to manage it. But for now, we're just going to leave it unmanaged until we figure out what happened with the person that we just deleted. Okay. Another option is the no action option. Now, what the no action option means is if a change to a parent table would result in violating referential integrity, then we don't allow the change. We reject that change, that insert or update or whatever. Okay, so that is definitely an option of how things could be done. Is we say, okay, you can't change course IDs anymore because if you do, it changes referential integrity. All right, it violates referential integrity. Okay, so those are 4 different ways that we can do it. On update, you can have one, and on delete, you can have another. You don't have to have it be the same one for both, right? So generally, What I would see probably most often would be on update cascade, and on delete would be set null is probably what I see most often. All right. William may have a different experience, but that's just my experience of how those tend to be done. Referential cycle. What is that? What do you mean by that? What is the referential cycle? Yeah, I don't know what you mean by cycle. That's what I'm confused about. Go ahead and type out what you're thinking there, because I'm can. Three tables reference. Are you talking about a trinary relationship? Because we haven't necessarily gotten to that yet. We haven't gotten to the ER modeling with the multi-table relationship. If that's what you're talking about. But because basically you can have a column that references a column in another table. I guess, are you trying to talk about a situation where maybe you have a table that references another table, and then this table has a foreign key to this table, and then this table has one there? If that's what you're talking about, where it kind of has this weird flow like that, I don't know if I've ever seen that. And it could cause for some really weird behavior, I think. I've not seen that before. If you've seen an example of that, you could share that with me and we could see what's going on there with why they designed it that way. But usually if there's three tables involved in a relationship like this, one of these is gone. Like basically one will reference this one, will reference this one, or this one will reference this one and it'll reference this one, something like that. Okay. It's an interesting idea. Let me think about what you're talking about. If you got an example, we can talk about it offline. All right. This basically defines in more words, just more succinctly, more briefly than what I just described, but essentially cascading deletes a row from a parent, delete matching rows in the child, and so on in a cascading way. Set null. If we delete a row from the parent, we set the foreign key to null. Foreign key columns must be allowed to be null. Set default. We must have a default specified for the foreign key column, and no action would reject any reject the change if it results in referential integrity being violated. Okay. All right. We can also have some general constraints, right? Such as here, we check that a staff doesn't handle more than 100 properties, right? For example here. Again, create statements will add something to the database, whether it be a table or a column to a table or a view. We can also alter these things. Generally, we don't alter view because when we do, if we need to change the definition of a view for some reason, what we would do is kind of have a if exists drop and then create it anew, create it from the SQL anew. We'll show you kind of how views work. Drop is how we get rid of anything in the database. We can drop the table, we can drop the view, we can drop a column. One thing I do want to point out is dropping also gets rid of the data itself. Okay, so if we drop a table, it will pretty much always ask, are you sure you want to do this? And the reason being is that once you drop the table, the data is gone as well. And that's what made that kind of opening comic funny, if you will, is that when you drop a table, drop the student table, for example, in the opening comic, not only is the table gone, all of the data in the table is gone. Okay, so if you kind of, not exactly, but if you kind of think about that the table is a folder and the rows within it are all the files in a folder, if I delete the folder, all the files go away, right? And one of the big problems with this is that, or one of the big concerns with this, why you got to be careful, is that if you do that, you can't really undo it. You can restore from a backup, but generally you can't get that data back. Okay, and so you can, like I said, you can restore from a backup if the backup was done recently enough, but once the data is gone, it's lost. Right. Okay, so that's why it'll ask you, are you sure? Are you sure you want to drop? Yeah. Let's see. So create schema, but let's move on to the more important one, the create table. You know, this is going to be a longer discussion than I think we have time for before the break is upon us. So let's do this. We'll take the break a few minutes early, about 5 minutes early. Let's break here at 11:14. We'll come back at 11:24 and we'll pick up the create table here, unless there are some questions or comments. Yeah, and William comments upon the chat saying about disabling constraints and then fix them manually after an upgrade and bulk import. Yeah, yes, it can cause some pain because we haven't gotten to that, the example of what happens if you try to insert and only one row isn't there. So we'll talk about that. All right. Okay, questions, comments before we break? 11:15, so we will come back at 11:25 and pick up at the create table script here. All right, see you guys in 10 minutes.